Welcome to a tutorial video on Unity plus Ink. In this video, I'm going to talk about building a better interface. So far in this series, we've dealt with bringing the Ink Unity integration plugin into Unity. We talked about going to the asset store, finding it, importing all the files. Then we, in the previous video, worked with the story API a little bit, looked at continue versus continue maximally, as well as current choices and working through that code. And as a quick review, let's jump over to Visual Studio and I'll show that code again right here. So just as a quick review, we loaded up a new story object. We created a new method, load story chunk, which used continue maximally to load all of the text into the next set of choices. And we used can continue to test if we could do that each time. We looked at the current choices, moved through those using count, and during each loop through all the choices, we were showing its internal text. And then we remembered that choice objects, which are within current choices, have both text and an index. And the index is what is used as part of the method choose choice index to tell Ink to that was the choice made. And in fact, let's go back to Unity for a second. I'll run this code again and we'll look at its output one more time. So with it running, come over to console and we see exactly what we expect to see. The text from continue maximally, the text of choice 1, the text of choice 2, text of choice 3, and then the text at the end once the choice had been made of 0, and we see choice 1, this is the end. And then we did it one more time to attempt to see if we could get any more story content. We could not, and so we got the empty string. So that's what we have from the previous two videos. We've imported everything in, and we're working with the API. So we want to start thinking about an interface within Unity. Using a script on the main camera is just not recommended. It's good for sort of testing purposes and getting our feet wet with this code, but it's not very efficient and it's definitely not recommended for more long-term and larger projects, which we're about to move into. So what we need to think then is something within Unity's AI or Unity's UI that gives us the ability to put different things together. An idea for that could be a canvas. So let's do that. So I'm going to come out of play mode. Over in the hierarchy view, I'm going to go to create, down to UI, and then down to canvas. So a canvas allows us to put different UI elements together. It is basically a canvas, a thing you paint on, more or less. So notice it defined a canvas space for us, and that's going to be the main thing we're going to work with going forward. We're going to put all of our UI elements within a canvas instead of part of the main camera. So to start that process, what we're going to do is disassociate the script file from the main camera and associate with the canvas, and then we're going to start writing code from there. So to do that, I'm going to come back and select main camera within the hierarchy view. I'm going to come down to Ink testing script component, and I'm going to click on the little gizmo, it looks like a little gear, and go to remove component. So we've not got rid of the script, we've just removed that component from that game object. So the main camera still exists, the script still exists, but now they're not associated together. So now we're going to move that to canvas. The way we do that is I'm going to click on canvas within the hierarchy view, go to its add component within the inspector view, scroll down to scripts, and then make sure I click on Ink testing script. Now, the Ink testing script component, which is a script, is associated with the canvas and is no longer associated with the main camera. But notice it also reset the Ink JSON field here. So we need to re-drag over the JSON text asset to make sure we have it. So I've put these back together, and now the script is associated with canvas. It's no longer associated with main camera. So let's play this. Notice we still don't see any visual output, but if I go to console, we see the same thing again. And in fact, I'll clear this and run it one more time so we can see that. And we see the exact same output again. So nothing has changed as far as the code understands. The script file, nothing has changed for it. It's still going along and doing its work with the story API. But within our organization, and especially our hierarchy, we've shifted what the script is associated with. So notice nothing really changed so far, but we've better organized how we're putting everything together. So I'll drop out of play mode. So now we're using a canvas, which is what we're going to add everything on. What is helpful about a canvas in Unity is it has a lot of special options that work with UI elements. The first of which, and which we're going to use throughout of this, is to help us organize things, is what's called layouts. So there's a couple of different choices when it comes to layouts within canvases. So with the canvas game object selected within the hierarchy view, I'm going to move over to the inspector view, and I'm going to come down to add component. I'm going to go down this time to layout. Now notice it gives me a few different options. I can do groups and scalars and fitters and grids and whatever. I'm going to come down to this last one and do vertical layout group and just click it to add that component. Now we're not going to do anything with it yet, but we need this on here. Now the reason we've added this is a vertical layout group will create things in rows from top to bottom. And notice this is child alignment upper left. It's going to start with the upper left, and as things get added to the canvas, it's just going to create more rows from top to bottom. What this means is that our initial text will get added at the top. And then, and as we work much later into this video, we add buttons. The buttons will get added at the bottom, one after another, which is basically the same layout we were seeing when we were working in Inky. That is, the text, the exposition or whatever we're dealing with, dialogue is at the top, and our choices, our options within Inky of what the user is looking at will be shown at the bottom. So we want to replicate that same sort of standard layout of text at the top explaining, and then our options at the bottom. So that's what the vertical layout group helps us with. So we've got that going on our canvas. We've got our canvas game object within our hierarchy view. Let's start to think about what we want to do now. So I talked about the title of this video is building a better interface. So far, we're just using debug log, which is not terribly useful. It's great for testing. It's in fact amazing for testing because we can see within the Unity log what's going on and we can test things back and forth. But as far as an interface goes, it's not terribly helpful. So let's think of the two things we want within this interface. I mentioned that with this vertical layout group, generally we want, and replicating that Inky interface, is we want a text at the top and then we want some buttons at the bottom. So those, in fact, are the exact game object types that we want to use. So they exist as UI game objects within Unity. We have a text game object and a button game object, and both of which are UI elements, which means we can put them on a canvas. This is the reason to have the canvas in the first place, in fact, so we can work directly with UI elements and put them all together in a central place. So we have our canvas, that's what we're going to paint on, and now we want to do text and buttons. Well, in Unity, one of the very, very useful elements is this idea of prefabs or prefabrications. We can create a game object, save all of its settings, and then instantiate it, that is, make a copy of it during runtime, and drag in all of those settings and then use it within another game object. This is incredibly helpful within Unity and helps us to write special things and set special settings, and instead of writing a lot of code to replicate that, we just create a game object that saves all that within itself as a prefabrication, and then we create a copy of that during runtime. So what this helps us to think through then is we want to create text with some options, and we may want to create a button with some options, but we don't want to deal with a whole lot of code or having to change those options back and forth. We really just want to write it in one place and then use it again and again and again. So create an initial blueprint copy, and then we want to just follow that blueprint anytime we create a new version of that. So I keep talking about text and buttons, so let's create those. So with canvas selected under the hierarchy view, I'm going to go to create, UI, and then text. And notice it added a text game element under the canvas game element within the hierarchy view. It also over here in the scene view showed us this little tiny new text, which is gray and pretty hard to see within a blue background. And it gave us some different options. We can look at character font sizes, font styles, line spacing, and everything. So let's go ahead and change the font size. I'm going to change this to 24 to make this a bit bigger, and notice it got bigger. And I want to change my color to white to make it more stand out on the blue. So we have white with font spacing 24 using the font Arial. Okay, well, we don't necessarily want the text on the canvas right now. What we want is a prefab of this exact thing we've just created so that it's saved and we can use it again and again and again. We do that by turning a game object into a prefab object. And the way we go about that is just dragging it from the hierarchy view to our project view. Well, in earlier videos, I keep talking about us wanting to better organize our project. So let's do that one more time here. Down within the project view, I'm going to click on Assets, go to Create, Folder, and I'm going to call this Prefabs. So now we have a Prefabs folder. Now I'm going to drag text from the hierarchy view down into the project view to the Prefabs folder. Notice it changed. It's no longer a sort of lighter white, grayish box. Now it is a blue one, and this tags it as a prefab. Well, now that we have this text prefab within our project view, we can delete it from the hierarchy view. So I'm going to right click and go to delete. So this game object still exists, but now it is a prefab within our project view, but not part of anything within the current hierarchy view. What this means is we can still change it. If I select text down here within the project view and then go to open prefab, we can still change its options, but now it's no longer associated within the current hierarchy. That is, it exists within the project, but is not within the current view of that project. So it's something we just sort of have out there that we can change. Notice it still has a font size of 24 and it's still white. So all of our settings are exactly the same. Now, whenever we're looking at something within a prefab, we can always click the arrow to go back and look at the current hierarchy view. So okay, we have our text. We also need buttons. So let's follow the exact same steps. Select the canvas, create, UI, this time scroll down to button. Then I want to leave its defaults like that, I think, where it's got its colors and normal colors. And I'm going to immediately drag button down into prefabs, and now we have a button prefab. And then I'm going to right click on the button within the hierarchy view and delete. So okay, within our prefabs we have our button prefab and we have our text prefab, and we can also change these settings and they will retain themselves. So this is particularly useful if we want to create a certain type of button or certain text styling. We can just save those as prefabs each time. So okay, back within our hierarchy view, again, we just have a simple canvas, but we have these prefabs we can start to build with. Now let's move over to the code for a second. It's coming down to Visual Studio. We're going to follow the same steps we did with text asset for using the Ink JSON. That is, we're going to create public variables that we can then change in the Unity editor to associate with them with the two prefabs we just created. So, public text. And now instead of pressing enter, I'm going to press right. And I'm going to call this text prefab. Now notice, just like before we were doing something with ink, the Visual Studio is getting a little bit confused because it said, oh, there's no variable of this type within our current scope. So right here, the type or namespace text could not be found within the current namespace. So we're going to click on Suggestions and Unity Engine UI. So now we've added all of those types to our file here. And notice text, when I put the cursor over it, says the default graphic to draw font data to screen. So let's follow the same model for button. So we have our text prefab and our button prefab. I'm going to press Control S to save this. Then I'm going to move back over to Unity. And now that it's updated, notice within our script component we have text prefab and button prefab, which is exactly what we want. Now, just like we did for the Ink JSON file, we're going to drag and drop text and button. So now we've associated the button prefab and the text prefab with those variables within our script file component. So now when we use this, those are going to be associated with it, and it means we can use those same values within this file. It's again particularly useful within Unity to create an example of what we want, disassociate it from anything else, so it's a prefab, and then use that prefab to create examples of that same thing. Useful to create all kinds of things in a number of different contexts. But in this, we're going to create texts and buttons, and so we need those blueprints, basically, the prefabs, to create them. So let's go move back to Visual Studio now that we've basically done what we want in Unity Editor. So let's look through this again. So we've got our start method, and it's doing a bunch of different things. It's loading the story, it's showing us the first story chunk, it's going through current choices, and more story chunk stuff going on. Well, let's start to organize this. So the first thing we want to do then is we want to actually start to use text for something. So text, and I'm going to call this story text, is equal to instantiate. So instantiate clones an object and returns that clone. And instantiate, what I want it to do is follow the model of text prefab as text. So we're saying, okay, what I want you to do is instantiate, clone, create a new object based on existing object settings as a text object and save it as the variable story text, which itself will be a text object. So basically we have the text prefab now within this as the value of a variable. So the next thing I'm going to do is, press the wrong key, is story text.text is equal to load story chunk. I'm going to Control X, Control V, and so now it's going to be the text. I'm going to take out this debug log line. And we need to do one final thing here, is we need to associate its transform with the current parent transform. What this basically means is associate these drawings together. Say, A, anytime you're drawing this, also draw this thing. Now it is a child of the existing parent. In other words, we're saying, okay, within our canvas, this text should be a child of this canvas. So we do that through going story text, transform, set parent, this transform, false. So notice the second option, world position stays. We say, no, everything should be done relative to the parent. And I'm going to Control S, save this. So what we're doing then is we're instantiating a clone of the prefab as text. We're loading its text, its internal, with load story chunk. So whatever the next load story chunk returns from that method. Then we're setting its transform to the parent of this, that is the canvas. And we're saying, no, don't change anything relative to its position. Let's jump back over to Unity, and now we're going to test this. We'll give Unity just a moment to catch up with everything. And we're seeing exactly what we expect to see. We see Hello World up here at the top. We see no errors in the console. But we also should expect more text, right? Well, this is actually part of what the layout's doing for us. So let's close this play mode, come down here in vertical layout, and say force expand height, or take off this, and now let's play this again. See, we're still seeing Hello World. And we're seeing that again. So what we should be seeing is Hello World more text. So what exactly is going on? Well, I'm playing with the layout to show our different options here. So what if I take all of these off? Well, we're still seeing Hello World. So what we're going to do is I'm going to set some padding here. And I'm going to say 30, 30, 30, 30. And go. Well, now we're seeing it correctly spaced, but it's not quite sure what we want. Let's expand the height and say the child controls the width and the height. Well, now we're finally seeing what we expect to see. So what did I just do? Well, I went through some different options here, and I set a minimum width and a minimum height for everything. So now it's coming in by 30 pixels padding for this. And I'm also said that child controls the width and its height. So it controls how big it can be. And I also said child force expand on height. So fill the entire thing. So I've added these different options here. But you notice I can play around with the vertical layout options. And it will decide how things are being positioned. So now we're saying, okay, go ahead and expand all of this for the child within this vertical layout group. And we've set some basic padding rules, so it's coming in by 30 on each side, all the way around the box, in fact, if we had full text for it. But now we're finally seeing the text we expect to see, hello world, and more text. So now that's finally working correctly, and we've worked with the vertical layout group to size the different rows in the way we want. So let's move back over to our code again. So this part of the code is now working as intended. We're creating a new text object that is a clone of an existing prefab. We're changing its internal text, and we're setting the parent transform of it to the canvas. So we're associating the text with the canvas. So now let's start to work through current choices. Current choices, this current loop right here needs to change a little bit. And the reason it needs to change is because what we want to do is we want to react when something clicks on it. So I'm going to solve a problem that's not going to appear yet by changing this code a little bit. So instead of for, I'm going to do for each. And instead of this current thing, I'm going to say choice in story current choices. So we're changing how this looping is work and making it more generic. I'm going to take out this code, and we're going to follow the exact same pattern we did for text and call this choice button is equal to instantiate button prefab as button. But now, and you may not know this, but buttons don't have text components. They have a child, which is a text. So if we want to get to the internal text of a button, what we want to do is get the text within its children. So now we're going to create a new text and call this choice text. Is equal to button prefab. And this time, instead of get component, which we've used in the past, we're going to say get component in children as text. So we're saying, okay, create a new button based on this prefab as a button. Now, within its component, within the components of its children, find the text and save that as choice text. I'm going to say choice text dot text is equal to choice dot text. So for each choice in current choices, this text will be this. Then we want to do the same thing we've done before and say choice button transform set parent this transform false. So okay, for every choice in current choices, create a new button based on a current prefab, get its text as part of a component of its children, change the text of its child to the choice text, or the text of the current choice, and set its parent, set the parent of the button to the current canvas, basically. So Control S to save this. Let's move back over to Unity to see this. Okay, and now we're seeing a little bit weird, so now we need to change our layout options. So if I change width, height, stop, replay, Oh, meant to change those before we replayed. Well, that's sort of what we want, right? So let's take off height and see what that looks like. Well, that looks more or less what we want, right? But now the other thing disappeared, so let's put that back in. Okay, well, these are not bad, right? So we have our text at the top, and we have our 3 different choices. So if I click on one of them, well, they don't really do anything. And it doesn't throw an error, but there's nothing really associated with them at the moment. So, and notice within our canvas during our runtime, we have our text, which is a clone, we have our buttons within a clone, and within the button is a child text, and it has the text we expect to see. So, okay. We set this up with the order we want then, and we're creating new buttons, which are based on prefabs. We're getting its text, changing its text, and setting its transform. Now we need to finally do something with this choose choice index situation. What we want to happen is when you click on a button, it chooses that choice, right? So what we should probably do then is separate out, instead of calling this multiple times, actually just put it into a new method. So I'm going to do that. Call this choose story choice. I'm going to pass it in a choice. Oops. And then I'm going to move this line of code 33, Control X, Control V, into this right here. And instead of using 0, I'm going to say choice.index. So what we want to happen is we're going to call this method, give it a choice, and say, okay, choose that index. Well, it still doesn't really solve the button problem, but it helps us towards solving that. So what we want to do then is we want to say choice button on click, add event listener. So we're going to add a listener that's going to work whenever this button is clicked. Then we're going to use delegate and an object where the content of this object is going to be to call the method choose story choice and with choice. So what did I just do? Well, I'm using the delegate keyword, and I've saved this to say, okay, what the delegate keyword allows us to do within C# is send in a method as the parameter for another method. And so basically we say, okay, this event listener is a method that's going to be called whenever this happens. And the method that's going to be called as the parameter to this method is choose story choice. Its parameter, its own parameter, that is, will be choice. So in other words, we're saying, okay, within this scope, we're going to be using this method, and it's going to be set up this way. So we've added an event listener to the onClick event. So whenever this button is clicked, this will be called choose story choice with the parameter of choice, and it will be the index that is sent into the story. In other words, we click a button and it moves the story forward, which is more or less what we wanted to do, but it's kind of a complicated C# setup here. And I Control S, so I save this. So let's move back over to Unity to test this, to make sure I got my own code right. Okay, so we have our text, we have our 3 choices, and if we click on one of them, well, nothing really happened. And now our choices are out of range. Well, that's weird. What in the world just happened? Well, we keep trying to make choices, but the UI wasn't updating each time. So let's drop out of play mode and think about the problem we just created. So we're drawing the initial text and buttons, then I was choosing a story option, but the UI wasn't refreshing. Okay, so if the UI wasn't refreshing, how do we change that? Well, we need to create a method then that does the same things we've been doing, but each time a new option is chosen. So an option is chosen, it redraws all of the UI, presents the most updated text and buttons options, and then allows the user to keep making choices. So okay, let's move back over to Visual Studio and start to think through how we might do that. So down here at the bottom, we really don't need these anymore, so we can take them out. And in fact, we should probably just move all of this stuff, what we've written this time, into its own method, because this is very generalized. It says, okay, get the next chunk if it's available. If there are any choices, draw them as buttons. That's pretty general. So this should probably just be moved into its own method at this point. So I'm going to go Control X and write a new method called Refresh UI. And Control V to put all that text in there. So okay, we just call refresh UI and it refreshes the entire UI for us. Well, we've run into actually another side problem, and I'm not going to play this so we can see it in fact, and I'm just going to solve the problem right now. So for refreshing the UI, we should probably also erase the previous UI, that is the UI each time, and update the UI. So we're going to delete any previous child components and then draw the new ones, and delete and then draw the new ones, and delete and draw the new ones. So, okay, pretty standard cycle, right? Basically a draw cycle. So get rid of what was previous there, completely redraw everything each time. And it's not going to be every frame or every loop. It's just going to be when the player clicks on the button. So there's lots of time between those, and it's not going to be terribly hard on the system. So, but we want to remember, we're going to start at the start method. So the very first thing we want to do then is refresh UI. And that will kick off all of our cycle. So what we want to do is create a cycle where every time a button is clicked, it does refresh UI. So in fact, I'm going to copy this, Control C, and come down to this and place it in here. So anytime we make a choice, that choice gets logged with a story and we refresh the entire UI. So I mentioned we also need to erase the previous UI every time. So to do that, let's write a new method. And we're going to call this erase UI. Well, now what we want to do is we want to go through all of our child game objects, destroy them all, and then we're going to have refresh UI make them all again. So we do that by using a for loop. And I is less than this transform child count I++. Well, we can't use the same generalized framework we used up here for each on line 30 because it doesn't exist for transform. And we remember each time we're setting these parents. So this transform will have children, that is, it will have text and button children. So we want to go through all of those children and pull them all out. So we're going to use destroy to destroy game object. And what we're going to destroy, the game object we're going to destroy, is this transform get child using its index and game object. So for each game object that's part of a child, that's part of transform, which will be text and button, because those are using the set parent methods, we're going to destroy them all. And then when we come back to refresh UI, we're going to redraw them all. So let's copy erase UI and put it at the top of refresh. And Control S to save. So the very first thing the very first time this happens, there will be no children, so it won't really matter, and then it will draw them all. The second and multiple times after that, if there are any existing children that are part of the transform, they will all get destroyed. The new ones will get created each time, which is what we want to happen. So let's look at this within Unity. I'm going to drop into play mode. Well, it says choice out of range. What just happened? So now we have an interesting error. Well, it showed us here that something is going on over here. So what's going on in this? We've got a new interesting error. Choose story choice. Okay. Let's drop out of play mode. Come on. Clear our console. And reload this. Well, okay. That was our error previously. So now we have our text at the top and our 3 different choices. If I click on one of these, choice 3, this is the end. Okay, okay. Let's redo that again. Choice 1. Choice 2, this is the end. So our text has gotten a little confusing, but the functionality is working correctly. What we're doing is we're erasing the UI every loop, we're refreshing it every time, and then if we click on everything, we're loading that into the story and going forward. And notice that there were no current choices. It returned empty text when it ran out of story, and it stopped. So something is going on with our layout, but everything else is working exactly as we want it to. So let's come back over to Unity, come back over to the canvas, and we'll play with our layout a little bit more here. Well, that's even better, in fact. If the child control size is width, that expands it all out exactly how we want. What if we adjust this a little bit? Okay, and this, and this. Our top to push it down, our bottom, our spacing. Well, this is one of the joys of working within the play mode of Unity, is we can keep playing with all of these till we get things exactly the way we want. So we can play with all of our layout settings and compose things exactly what we want. But as a review of this video, we've moved from our basic playing with the story API to building a better interface. We did that first through removing the script component from main camera. We then added a canvas game object and associated the previous script with the new canvas game object. Within canvas game object, we added a vertical layout group. And we can also use the other layout group options and lay out things different ways. We then, within our code, prepared it for loading things in a more generic way. We went about doing that by creating 2 different prefabs, a text and a button, down here within our prefabs folder we created. And this allows us to basically create a blueprint, an existing game object that's not associated with anything, and allow us to instantiate it, that is, clone that game object and its settings and use it within our runtime. Within our file, We then created public variables to be associated with those prefabs. Then we more generalized our code where we're creating the text objects that are instantiating those prefabs. We changed this text and we set its parent to the current canvas. Then we did a similar thing where we moved through current choices, creates new buttons existing as those prefabs, look for its text within the components of its children, change its text, set its parent. Then we added an event listener using a delegate, which allows us to use a method as a parameter to another method, and said, okay, whenever this on-click event happens, choose story choice, sending in a choice object. Down here in story choice, we said, okay, this will be the index it uses, then refresh the UI, which kicks us back to the top. It erases any of the current UI by going through any of the children that are part of its transform, destroying them, and then redrawing them each time. So we see a very generalized interface for using ink, and this will work through the text and the choices of anything we could create within ink at this point. We could use different diverts to move through different things, but as long as there is text and choices, this will handle that very generalized way of doing that. We also remember, because they're prefabs, we can go in and change the text and the layout of the buttons and devise them and scale them in different ways. Because we are instantiating those prefabs, we're cloning those game objects. And that allows us to set a bunch of different settings on those game objects and reuse them in the setting without needing to write code for that. The game objects are just saved as prefabrications, clones, we can then just use when we're creating things. And as we remember, we're using a canvas game object within Unity, so we're using UI elements, text and button in these cases, and drawing them to a canvas using the vertical layout system as a way to construct different rows. And we tweaked with the settings a little bit and saw how we can make the buttons bigger and smaller and padding in different ways and have the children expand and whatever, remembering that those are part of Canvas and allows us to play with those layouts. Thanks for watching.